Hi, and welcome to video 4 of 4 videos for section 1.6. This is actually the last video for chapter 1 as well. Let's think about what we've been dealing with. So section 1.6, we're talking about infinity now. We had that limits were going to infinity. We had that x was approaching infinity, plus or minus. This last video, we're looking at infinite limits at infinity. So we're putting it all together now. So let's look at the function x to the third power. So if I draw this, this is what? This is kind of this snake-looking graph, goes through the origin. So as I go to positive infinity, where's my limit going to? Positive infinity. As I go to negative infinity, where's the graph going to? Negative infinity. So that tells me that the limit, if I put that into formula form here, the limit as x approaches infinity of x to the third is positive infinity. And the limit of x to the third as x goes to negative infinity is negative infinity. So the further I go to the left, the further down this graph goes. The further I go to the right, the higher this graph goes. So let's look at an example. So let's find the limit as x goes to infinity of x squared plus x over 3 minus x. So we did an example similar to this in video 3, right? We had a rational function. The limit was going to infinity. We wanted to find out what is this limit. So what did we do? Remember, I wrote it in the red marker instead, with the whole point of trying to get your attention that that's what we want to do. We divided by what? We divided by the highest power of x in the denominator. So not just the highest power of x in the whole rational function, but the highest power of x in the denominator. So try that here. Go ahead and hit pause if you want. Our highest power of x is what? Just x to the first power. So divide every term by x to the first power, simplify, apply your limit, x approaches to infinity, and see what value you come up with. All right, welcome back if you gave that a shot. So again, I'll switch colors just to keep clear what we're doing. We're going to divide every term by the highest degree in the denominator, which is x. So that gives me what? It gives me the limit as x approaches infinity of x squared over x plus x over x divided by 3 over x minus x over x. So when I do that and simplify as x goes to infinity, first term, what? 1 in the numerator cancels with 1 in the denominator, so I'm just left with x plus x over x is 1. In the denominator, 3 over x, that doesn't simplify, minus x over x, which is just minus 1. The x's cancel, I'm left with negative 1. Now go ahead, apply this limit to each piece, see what we get. So the limit as x goes to infinity, if I plug that in, I get what? Infinity plus 1 all over. As x goes to infinity, this first term in the denominator goes to what? Goes to 0. I have the x in the denominator, minus 1. So infinity plus 1 is what? Just infinity. Like when you used to have fights as kids, you know, oh, I do this infinity plus 1. It's still just infinity. All over -1. So infinity divided by -1 becomes what? Negative infinity. So the limit as x approaches infinity of this rational function is negative infinity. All right, so on page 64 and 65, there's more precise definitions and proofs again for some of what we looked at. Again, that's not the purpose of these videos. That's maybe class time if you have a question with your instructor, office hours maybe. I just want to kind of give you guys the base, the overview of everything to kind of have you have a grasp on it, not delve too much into the real technical proof side of it. That's it. That's the end of chapter 1. Come on back and we'll start looking at chapter 2, which is derivatives.